Okay, welcome to part two of the videos, and let's continue with our electrophilic addition. Right, so now I'm going to do HBr. Now, which end is going to add first? Which part of the HBr molecule is going to attack my double bond? Do you think, either of you? You've got HBr. Which side is it going to be? The H going to attack, or the Br that's going to attack my double bond? What do you think? Well done. It is that exactly, Tamani. Well done. It's the H side, isn't it? Now I'm going to do this in a different color. Let me do this in green. So now the H is going to attack first. Why, by the way, Tamani? Well done, Lungi as well. Why is the H going to attack first? Either of you could answer. Exactly. It's not a full positive charge, though, is it? It's a partial positive charge. So we do plus, minus. Which one, what's the difference between this molecule and the bromine molecule? Anyone? Which one is, what's the difference? That we originally used the bromine molecule. Tamani, your microphone's on. I don't know if you want to say something. Exactly. That's exactly it. All right. Now, if in the case of the bromine, there's my bit. Oh, that's not a nice color, is it? In the case of the bromine, if you remember, the bromine is a non-polar molecule, but the HBr is polar. So this is non-polar, and this one is polar. Okay. Why is it polar? Because there's an electronegativity difference between the H and the Br, isn't there? All right. Now, if you remember as well, in this one, we had to have, when this was attacking, we had to have an induced dipole on this one. But HBr has a permanent dipole. So this is the question. Which one's going to react faster, do you think? The Br2 or the HBr? Which one's going to attack quicker? HBr or Br2? Yeah, it's going to be the HBr because the dipole's there all the time. But you know what? Except other than that, is everything's exactly the same. All right, these electrons come out to capture this. These electrons go over here. And don't forget, we're using full curly arrows. All right. And full curly arrows means 2 electrons moving. All right, and that's important, okay? Now, I don't think I'm going to keep changing color here, even though it's nice, isn't it? All right, maybe I will. We get the H, the C, there we are. And we have this, what color is it? Green. We have the H, this is the new H. This guy, I should have more colors than this, shouldn't I? This guy is the positive charge, and down here is the Br minus. There. By the way, this is a technical thing, but you see I'm drawing these 2 electrons here and the positive charge, the negative charge here. You must do this. Okay, it shows it has a spare pair of electrons that are willing to bond. So you've got to put these electrons there and you've got to put the charge there. All right, you've got to do it when you do mechanisms. All right, it's just one of those things. Now what happens now? Well, these electrons go up to attack here and we get the product. And what's the product? I'll do it in a different color. And we get this color, then we get H there, and Br there. And we get bromo, ethane. Yeah, I think we're good. All right, so we've done that one, and we've done that one, okay? All right, can someone tell me something interesting about this bond? What's interesting about that bond? It's kind of interesting anyway. What's interesting about it? Anyone want to tell me? IDK, down thumb, anything? Down thumb is easier, I think, isn't it? Well, it does make the molecule polar, but that's not what's interesting about the bond, though. No one knows. Now, I think this is a term that you don't use, but I do use. But you have a term for it. This is a dative bond, isn't it? What would you call that? You guys, you've got another name for it. As what? Okay. Oh, I thought you. Oh, sorry, Tamani. I thought you used the term coordinate. Yeah. Oh, I'm sorry. All right. Now you're right then. No, I'm sorry. I thought you used the term coordinate. All right. Well, it's the same thing. It's coordinate bond, dative bond, same thing. But do you see it's a dative bond? You're happy you can see it's a dative bond. Yeah. Interestingly, this one is as well. Yeah, I hope that makes sense. They're both dative bonds. Now, you don't do this. What I'm going to do, I don't want you to do, okay? I'm just going to do it for illustrative purposes. So I'm going to do something now, but I don't want you to do this, all right? That's your product there, okay? And if you wanted, you could do this, couldn't you? The dative bond, the electrons come from the carbon, and the dative bond on this one, the electrons come from the bromine. Okay, so we show arrows to show the directionality of the dative bond. In other words, where the electrons come from. All right, but well done. You're exactly right. Sorry, I get a bit confused. I'm getting old. Okay, guys. Anyway, so we've done bromine and HBr. Now, what we're not going to do, I've decided we're not going to do this one for now. Why aren't we going to do hydrogen? Why don't you think we'll do hydrogen? What's it going to be exactly the same as? Anyone? Why am I not going to bother doing this one? No, it doesn't put hydrogen gas. Hydrogen gas comes in. Oh, shall I do it? The reason I didn't want to do the hydrogen is because it's exactly the same as bromine, isn't it? Exactly the same. Yeah, you have a non-polar molecule coming in, it gets an induced dipole, and it adds. It's not interesting, really, is it? It's exactly the same as bromine. Do you follow that? That's why I don't want to bother doing the bromine. Are we good? Are you happy for me not to do it? Yeah, long as okay. All right, no problem. All right, but I am going to do water, okay? Because water is not a special case. It's exactly the same mechanism. And I'm doing this for a reason, guys. I'm doing exactly the same so it gets in your head, seriously. Because this is important. All right. Now we're going to do hydrogen. No, we're not. We're doing water. So now H, oops, I want a different color. I don't want the same color. H comes first. And then we tend to do that with water. We call it H and OH. So the reason we do that, or let me pick this color, is then we can say the water, the hydrogen is delta plus, and this side of the molecule is delta minus. Okay. Now, what happens? I'm going to do this very quickly because I think you both understand this too well. Electrons come out to grab this. This goes onto there. Okay. What do we get? We get this. I'm not even going to bother changing colors now because I think you get this. We get this. And down here, we'll have an OH minus ion with its electrons. The electrons will go up to there and we'll get the product, which is ethanol. Okay. So this is the addition of ethanol to ethene, I think, yeah, ethene. All right, so this we started off with ethene, and we end up with ethanol. Okay, do you get that? Exactly the same. All right, exactly the same mechanism. They're all electrophilic addition mechanisms. Okay, they're all electrophilic addition. So are we all happy? I'm going to ask you a question now on this. Are we all good with this? Excellent. Lungi's good. Tamani, excellent. Right, now I'm going to give you a question, a multiple choice question. Okay, number one is this. These are the answers, guys. There's answer number one. Answer number two is this. Oh, no, it's not. Answer number two is this, Cl there. And answer number three is this, Cl and Cl. All right, they're the three answers, and this is the question, okay? I'm going to pass chlorine gas. No, I'm going to pass bromine. Oh, what am I talking about? All right, I'm going to add bromine. Yeah, sorry, I'm confusing you, aren't I? Let me get rid of this. I've actually done it a tiny bit wrong, but it doesn't matter. I've got this beaker. There's my beaker. There's my lovely beaker. And inside the beaker, I'm going to pass, I've got bromine water, okay? This is bromine water, Br2 aqueous, okay? But as well as bromine water, I have dissolved sodium chloride aqueous in there. So I've got two halogens in there. Well, I've got a halide, haven't I? I've got chlorine ions. I've got Br2 aqueous and I've got NaCl aqueous. And now what I'm going to do, which I should have done before, oh, that's not good, is it? I can just draw shift. I don't know why I bother doing that. There's one and the other one. And into this mixture, I'm going to bubble chlorine. No, I'm not. Why do I keep saying that? I'm going to bubble ethene. Ethene. Okay, and now this is a tricky question. It was a question a few years ago on a paper. Ethene is bubbled in to a mixture of Br2 and NaCl aqueous. Which products are possible? Is A possible? Is B possible? And is number one possible? Is number two possible? Is number three possible? Which ones are possible there? 1, 2, or 3? Which products are possible? See if you get the mechanism. If you understand this question, oh no, there will be no there's no displacement. I'll tell you why there's no displacement in a minute, okay? You won't get displacement in this case. Which ones are possible? 2 is number 1 possible? Let's start there. Do you think number 1 is possible? All right. Now, to be honest with you, this is quite a tricky one, eh? So maybe I should go through this one because this is one of those ones. If we did it in class, it would be easier. Is number 1 possible? Yes, number 1 is possible. Because what happens to get number 1? We have what we get is this. We have our ethene, and bromine comes along, and this comes down here, this comes down here, and we get this. We get a Br here, we get this, and this, and this, and then the Br minus does that. So, and that gives us number 1. Do we both understand that? Number 1 is very possible. Are we good? That's exactly what we've done all morning. Number 1 is possible. Okay, Damani, how about you? You good? Are we good? Excellent. Is number 2 possible? Well, yes, number 2 is possible. Because what happens with number 2? Well, this happens, first of all. And then you get this intermediate here. And in the mixture, if I've got bromide ions and I've also got chloride ions, they can both attack this carbon. And if the chloride gets there first, we'll get number 2, won't we? So number 2 is possible. Do you see that? Because I've got chloride ions in the mixture, the chloride ions can overtake the bromide ions and can give me the product. So number 2 is possible. But is number 3 possible? What do you think? Can I get 2 chlorines on? And this is where your understanding comes in. Number 3 is the hard one. We cannot, Timani, we cannot get number 3 because to get number 3, what would have to attack the double bond to get number 3? Yeah, and do we have chlorine gas? All we've got, well done, I think you understand it. All we've got is chloride ions. And will a chloride ion attack this double bond? Anyone? No, it won't, because the double bond is negative. Well done, Longy. And the chloride ion is negative. So you can't put the first chlorine on because nothing will attack the neutral molecule. Once the molecule is charged,